Okay, so remember where this line is on our notes. Everything before it is going to be one quiz. Everything after this line is going to be the second quiz. Okay, so let's go ahead and start off. This is actually, originally it was a new set of notes, but remember we're combining two units into one. And on this part, we're going to start talking about naming. Okay, so let's talk about how do you name a compound. Okay, well, first thing is we're going to start with covalent compounds. And remember, what was covalent? Covalent was a nonmetal and a nonmetal that was bonded together. Okay, two nonmetals. So let's start off with covalent naming. Let me go ahead and here's what we're going to do. Okay, so it says here naming binary molecule compounds. Binary molecule compounds are composed of two nonmetals, no metals or ions are part of this. So again, one more time, binary molecular compounds do not include metals or ions. Okay? Next thing, part 2, it says over here, rules for naming binary molecular compounds. First, it says here, first name the element in the formula first using the entire first name. So the first name is using the entire first name. The second element in the formula is named using the root of the element plus a suffix. IDE, IDE. Prefixes are used to indicate the number of atoms in each type present in the compound. So prefixes are used. Okay? So that's first name, second name, including this rule over here as well. Let's don't forget that. Now let's come back over here to the second one. For an example, if, let me come over here. If the second element is oxygen, for an example, it's going to have the root of that element, which is ox, plus the suffix ide. Oxide. Okay? So, again, remember, this is two nonmetals that are being bonded together. Now, the next part over here in our notes is the actual prefixes. Okay? And those prefixes over here are probably going to be something familiar. You probably already learned this in math class, right? When we're talking about 1, it's mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nana, and 10 is deca. Okay? So again, these are prefixes. Those are not on the formula chart. They are for memory. Okay? But you probably already know them. Says here, there's an exception to the rule. Remember what I told you, before we even started the second semester, we're going to have a lot of exceptions. And here's another exception to the rule. If we're talking about the first element, we do not use mono. No mono. So if the first element is a single atom, okay, we do not use mono. If the element name begins with a vowel, drop the last vowel in the prefix. So for an example, CO, carbon and oxygen, is carbon monoxide, not carbon. It's not monocarbon monoxide, or it's not going to be carbon mono, two O's. That's not going to cut it. Okay, so here, what are we going to do? It says here that we're going to drop the last vowel in that prefix. Okay, so there we go, monoxide. Again, though, don't forget we do not use carbon for the first name. let's go ahead and practice this so that way we can see how we do. Again, it's just going to be a lot of practice over and over and over so that way you can get it. Also, though, before we go any further, diatomic molecules. Remember those 777 rule? Okay. It says here, though, you're just going to name the element. So if it's H2, which is a diatomic, you're just going to call it hydrogen. That's it. Simple. O2, which is 2 oxygens, and that's a diatomic molecule. They always come together as a group or paired. You just call it oxygen. That's it. Plain and simple. So let's go ahead and practice this, and then we're going to get to ionic compounds that includes metals with that. Okay, so let's go ahead and practice over here. So first thing is, we're going to have prefixes for the first and the second name. We do not use a prefix if it's a mono on the first name. Okay, let's don't forget that. Then after you use the prefix for the first name, then you just go ahead and write out the full first name. For the second word or the second element, you're going to use the prefix, the root word, and then IDE for Id, and that's the suffix. So let's go ahead and let's practice. There is a 2 here, and that's P for phosphorus. So 2 is going to be a di. And then we include the whole word phosphorus, diphosphorus. And that di, or that di right here, indicates that there's 2 atoms of the phosphorus. So diphosphorus. There's a 5 here. So let's use the prefix. The prefix for 5 is penta. This is oxygen. Let's use the root word. Ox. Let's see. Let's go to penta, ox, and then there's an ending, ide, I-D-E. Okay, diphosphorus pentaoxide. Let's practice again. Over here in part B, I use a prefix for the first and second element, except we do not use a prefix when there's a 1. Remember that 1 is invisible, which is mono on the first name. So instead of putting mono, we're just going to use the whole first name. There is no prefix here. It's just going to be carbon. So carbon. There is a 4 over here, so we are going to use the prefix for 4, which is tetra. Tetra. This is bromine for Br. Again, we're only going to use the root word, and then we're going to add ide. So brome, and then ide. I-D-E. Carbon tetrabromide. That's the full name. Let's come over here. I see a 1 that's invisible behind the S and a 2 that's behind the O. We do not use the prefix mono for the first name, so we're just going to use the whole first element and just name it as is, which is sulfur. The second element is oxygen, but it has a 2. So the prefix for 2 is di. The root word for oxygen is ox. And we always, on the second element, add an ending or a suffix of IDE. Sulfur dioxide. And that's how we name it. Let's go to the next one. I see a 2 and I see a 3. So we're definitely going to use both prefixes. 2 is di, so di. Arsenic. E-N-I-C. Tri for the 3. Ox for the oxygen. ide, diarsenic trioxide. Okay? So let's keep going. Let's practice through this. I know you're gonna get, it's gonna get better and better and easier as you continue to practice. Carbon has a 2, hydrogen has a 6. So please make sure you definitely look at those subscripts, those little numbers behind. That tells me, what does that tell me? The number of atoms. This is what kind are we talking about right now? Covalent bonding. And what did we learn in this unit of notes before? On covalent bonding, we do not reduce. So that means however many numbers of atoms there are is the number that we're going to get here. There is no reducing. But don't forget though, when it comes to ionic compounds, we do reduce. All right, so let's go ahead and come back over here. Dicarbon. 6 is going to be hexa. Hide. Ride. Hydrogen, and then IDE. Dicarbon, hexahydride. I know, it's just weird. I get tongue-tied trying to say some of these words, so I apologize. Next one here, sulfur has a 1 behind it, and phosphorus has a 6. We do not use mono on the first one, so we're just going to call it sulfur. 6 is a hexa. F is for phosphorus. Fluorine. I'm so sorry. P is phosphorus. I apologize. F is fluorine. So fluor. And then the ending IDE. Oh, now they want you to go the other way. Now they're giving you the name and they want you to write the actual, I'm sorry. They want you to come over here and flip it, and now you write the formula instead of the name, and they're giving you the name. So let's look at this. I'm going to go back to my orange for my prefix, di, penta. Okay. Don't forget we have a suffix, ide, and we have the first one has the full name, and the second one has the root word. So first thing is, the first element is going to be nitrogen. The second one is oxygen. The first one is di, which means 2. And penta, which is going to be 5. But let's pause for a moment. Penta is spelled with a and oxygen. What is the rule? When you have 2 vowels next to each other, you're going to drop the last vowel on the prefix, and it's pent-ox-ide. Okay? See that? Remember that rule, which is over here. This rule up here, letter E, look at it. It came in place over here. Okay, let's keep going. Sulfur. I'm going to go back to my blue. My root word is oxygen. My prefix here is tri. There is no prefix here. So that means what? It's a mono. And then again, the second word is always going to have an ending of IDE. So let's go ahead and write that in. Sulfur, which is an S. It's a mono. So that means we don't write a number 1. That's invisible. Oxygen, which is the next one. Tri, which is a 3. And then we're not going to do anything, because we know that that's just the suffix, the ide, on the second word. All right, let's keep going. Sulfur, dinitrogen. I'm just going to go ahead and try sulfur, nano, oxide, oxygen, and then that's just N. Okay, I'm going to come back over here with my prefix and my orange just for myself, just so that way I can keep it organized. Tetra and di, tri, nano, or nano, not nana, nano, nah. I'm sorry. See, again, I'm getting tongue-tied. N-O-N-A. Look at this over here. It should be this. It should be N-O-N-A and then oxygen, O-X. What is the rule? The rule over here on letter E says if you've got two vowels that are next to each other, you drop the vowel on the last vowel on the prefix, and that's how you write it. And you can see that they wrote it the correct way. Okay. So let's go ahead and write this one. Sulfur, tetra. So what is tetra? 4. Nitrogen, N. What is di? 2. Sulfur, S. What is tri? 3. Oxygen, nana, which is 9. Let's keep going. Oxygen. How do we write the formula for oxygen? O2. Why do I put a 2? Because it's a diatomic. N2. How do we write the name for diatomics? We just write the name. That's it. So it's just going to be called nitrogen. Okay, so that's the rules. Again, it takes some practice, but I think it's pretty easy. This is memorization, and the rules are memorization, okay? Don't forget, of course, we got exceptions, and we've got rules to go along with it. And ionic compound naming is going to be kind of similar. So let's go ahead and look at that. I'm going to highlight the word ionic because that's what we're going to talk about now. All of this was covalent, which is two nonmetals bonded together. Now we're going to get to ionic, and let's talk about that ionic. We know that ionic is going to be a metal and a nonmetal. And what did I do? I wrote metal first because metals always go first. Metals go first. Just as a reminder, metals go first. Okay, so naming, and we call it nomenclature, rules for monatomic ionic compounds. Name the cation first, and then the anion. What is the cation? The cation, don't forget, is the metal, and the anion is the nonmetal. So just as quick reminders, I'm just going to write some little notes out here. So metal, and anion is going to be the nonmetal. All right. Part B. We're looking at our rules. Monatomic cations use the element name. For an example, cesium. Monatomic anions take their name from the root, and then we add a suffix IDE. Okay, so the first one, which is going to be the metal, it's going to use the element's name all the way across. Use the element name, which is the metal. The nonmetal, which is the second name, is going to have the root of that element plus the suffix IDE again. So that's not too bad. That's kind of similar to what we already did. So let's look on this side. We're going to go straight into practicing. I mean, those rules were pretty easy. Did you see something that we did not say like we did earlier? Remember when it was the, when we were talking about the, my mind went blank, covalent bonding? We had prefixes, but here on ionic bonding, we didn't say anything about prefixes because there is no prefixes. How easy is that? That's pretty easy. So you're going to name the first one, which is the metal first, and just give the full name. And then the second element, you're going to give the root and then IDE. That's it. it's even easier to do those. So let's come ahead and let's practice over here. We got SR, which has, it doesn't matter the numbers behind it, right? Don't forget though, we do reduce. And because of the reducing, that's a reason why we don't use the prefix, because it could be, we can have a 1 and a 2, and it really could be a 2 and a 4 because we reduced it to a 1 and a 2. Then the prefix is going to be wrong, if that makes sense. So that's the reason why we don't use prefixes, because they are reduced. Now let's go ahead and look at the first one over here. Stromium for SR, and then I is for iodine. Okay, it doesn't matter the number that's behind it, the suffix number. So let's go ahead and write that in. Stromium. And then iodine, I-O, died, I-D-E, Ide. Magnesium, we're just going to write the name as is. And then sulfur, sulf. And then Ide, I-D-E. And A, which is going to be sodium. We just name it as is. Oxygen, we're going to use the root, ox. And then we're going to add the suffix ide, I-D-E. That's it. It's really easy. Lithium, just write the name as is. Don't have to change it at all. Phosphorus, we're going to go with the root, falsified, I-D-E. How easy is that? Pretty easy. I would have to say between the ionic and covalent, definitely the covalent is a little bit more rules to it. And the ionic is very, very simple. Okay. Now it says here, write the formula for the following ionic compounds. This is the name. We're going to write the formula. This is what they're talking about, the formula. So stromium, chlor, and then the suffix ide. Potassium, chlor, and then the suffix ide. Okay, we don't do anything with the suffix. It doesn't matter. Okay, so stromium is going to be SR. Chlorine is going to be a Cl. But wait, we've got to remember, what did we do in the beginning of the notes here? Like all the way from page 1. Remember page 1? We did what we call crisscross. Okay, so I'm going to go ahead and put a little note over here. When writing the formula for ionic compounds, do not forget to crisscross. Okay, I know, I'm sorry. I just like to write a lot of notes in between our notes. Little notes here just to kind of help remind us. We need to go back and crisscross because we need to put those little numbers. Do you see how those little numbers are here, here, here? Yes, there's some here. They're invisible. They're there though. But we need to add numbers to it. So we got to crisscross. And how are we going to crisscross? We're going to crisscross backwards. Or we're going to crisscross. We're just going to crisscross. And I didn't mean to say backwards. We're just going to regular crisscross. How do we crisscross? We go over to the periodic table. Look at the top. And at the top, you know what those group numbers indicate? They indicate the number of valence electrons. But remember, they want to get to the number 8. We call that the octet rule. For them to do that, they're either going to gain and add more electrons or they're going to give those electrons away, right? When they gain and add more electrons, they have a negative charge. Why is it negative? Because they added more negative electrons to them. And if they give away electrons, they have a positive charge, because they have more positive protons than negative electrons. Okay, so let's go ahead and let's go over there and let's do that. Stromium is going to be a +2 charge. Remember, all metals have a positive charge. Chlorine is a -1 charge. And then we're going to crisscross. So in this case, it's going to be SR. We're not going to put the number 1. It stays invisible, but the chlorine's going to have a little 2 behind it. Now we're done. Okay, so when it comes to naming ionic compounds, it's really easy, but sometimes we forget we've got it crisscrossed over here. All right, so if students have a mistake, it's coming up with the formula and they forget the crisscrossing part. Okay, potassium chloride. Potassium is on the periodic table. It's in group 1. It has a +1 charge. Chlorine is a -1. It's over there in group 17, but we're going to crisscross them. Okay, what do? We ignore the number 1 because they're invisible. So we're just going to go ahead and write it as is. Potassium is a K, chlorine is a Cl, and we're going to leave it as is. Do not add any numbers behind it because they're invisible. Hopefully that was pretty easy. I'm hoping. Okay, but now we're going to go to transition metals. So I'm going to go ahead and highlight that because this is the next topic of naming. Okay, so it's still ionic compounds, but in this case, though, we're going to have transition metals. And remember, earlier in our notes over here, what did we say about transition metals? They have parentheses behind them with Roman numerals. And the Roman numerals are there because transition metals have more than one oxidation number. Okay, so that's how we know the oxidation number from the Roman numeral numbers. Okay, and then if we needed to, we can crisscross backwards to see what that Roman numeral number was. Alrighty, so let's go ahead and let's look at the rules and let's name those, and then we're going to get to polyatomics. Alrighty, and then after that we're not done because we're going to get to acids at the back. Okay, and then we'll be done. Alright, so let's go ahead and start here. Okay, so transition metals. It says here, let's follow the general rules from above, which was those ionic compound rules on the previous page. Okay, but to distinguish between multiple oxidation numbers, right? Because that's what's special about transition metals. They have, and I'm just going to go ahead and just, I'm going to add some more notes. More than one oxidation number. Of that same element. The formula name. And right, how was it? It's in parentheses with Roman numeral numbers. So don't forget that. I'm adding that there too. If you wanted to, you can put that over here. In parentheses, you know what? I just want to make sure that we have all of our notes just to help remind us. In parentheses with Roman numeral numbers. Ooh. And I just completely just destroyed the word Roman numeral. No. And I still misspelled that one. I just butchered that word completely. I apologize. Numeral. Numeral. There we go. That's a lot better. All right. So, just for a reminder, let's keep going though. The formula name must indicate the number of oxidation number for that cation. Don't forget though, it's going to be a positive oxidation number because metals are positive cations. The oxidation number is written as a Roman numeral number in parentheses after the name of that cation. And we wrote that over here for some little side notes. It says here as an example, the compound Fe, which is iron, and then O for oxygen, was formed by an Fe+2 and an oxygen -2 formula. So this is going to look like this. It's going to be iron, Roman numerals 2 inside the parentheses, oxide. So it's still going to pretty much use the same thing. It's going to still have the name as is. There is no prefix. The second one's going to have the root word, and then it's going to have "ide" The only thing that's going to be a little special is that it's going to have the parentheses there. Okay, let's go ahead and let's look at this one. Now, the compound Fe2O3 indicates that this is iron plus 3. Now, how do I know it's a plus 3? Because in this case, we are going to crisscross backwards. So here and here. That's how we did that. That's how we found a 2 and a 2. But Miss Munson, that doesn't make sense because those are actually the number 1, invisible. I hear you. But when I crisscross backwards, the oxygen, if you go to the periodic table, it's going to have a -2 charge because it's in group 16. So how do I know, Miss Munson, that that's a +2 charge? Because don't forget we reduce. So I'm going to go over here. Oops, nope. This word right here. Ionic compounds, reduced. They are reduced. So don't forget that. Because ionic compounds are reduced, then in this case, if this is a 2, that's a -2, and look over here, it's a 1 and a 1, then this must be a +2 that got reduced to a 1 and a 1. That's how I know it. Okay? That's how I know this was there. So let's go this way to this one. Let's crisscross backwards. Here we go, and here we go. Now, in this case, the iron is going to be a Roman numeral 3, because this 3 crisscross backwards. So 1, 2, 3, oxide. Okay? Iron 3 oxide. So let's go ahead and practice this. It's just, again, it's going to take practice. There are a few more rules. Don't forget about the Roman numerals and the parentheses. We need to crisscross backwards also when we're writing out the form and when we're writing out the name. And don't forget that they had been reduced. So it may not look like, it might be looking like a 1 and a 1, but it's really a 2 and a 2. So don't forget that. Let's go ahead and let's look at this one. FeCl3. Okay. So Fe I know is iron, and I know Cl is chlorine. But what happens here? I need to go and crisscross backwards. Okay, first. So Fe1, and that's a -1. Chlorine, get that 3, and that's a +3 charge. So Fe actually has a +3 charge. So iron, okay, let's do the parentheses. 1, 2, 3. Chlor, ide. All right, we did it.